All right, guys. So yesterday I had you do this activity, Desmos discovery activity, and hopefully this was really helpful to help you to kind of see visually what happens. I'm a very visual person, so this kind of thing really helps me. But again, you were supposed to walk through this little activity, and it was going to show you some different things. You were supposed to start it with the parent graph, and then put in different equations for the other lines under it. Which would help you to try to maybe see these transformations. And so I want to walk through this real quickly, and then we're going to focus down at the bottom of this form at something that I had for you on one of the last questions. So I'm going to go ahead and bring up a Desmos screen, and I'm going to go ahead and put the parent graph in here, y equals x squared. And again, this little keypad down here can help you try to put in some of this stuff for you when you need it to. So there is the graph of y equals x squared. This is kind of the parent graph. And when we get into chapter 4, which is on quadratics, you're gonna be so tired of this that you're gonna be just absolutely exhausted. But again, we're kind of getting ourselves ready for that thing, and we're going to set up a lot of things that's going to help us in the future. So this again is your parent graph, y equals x squared. And again, one of the things I had you to do was, for example, to put in y equals negative x squared. You will notice as soon as we do that, that it creates a reflection. Just think of yourself standing on banks of the lake. Well, shoot, we're close to Buckhorn Lake. We might as well talk about it. So if you were standing on the edge of Buckhorn Lake, say down at the spillway along the bank, you would see your reflection in the water. So basically your feet are down near the water, but then when you look at your reflection, your head is furthest away from you. So it's really the same way here. This is exactly the same graph. The blue graph is the same as the red one. It's just reflected across the x-axis. Okay, so let's take another look at maybe a different situation. So I'm going to go ahead and erase out this negative here. And over here, I'm going to go ahead and put in a positive 3. Let's do that. So if you notice here, and this is kind of an optical illusion a little bit, it almost looks like we've got two different graphs, but it's just because of the way that these are kind of stacked on one another. I promise you that these are exactly the same graph. The only difference is this blue graph right here is shifted up 3 units from what this graph is. So what I want you to notice is out here to the right side of this x squared, if I have a number out here, it is going to change vertically, and it's going to be literal. So what I mean by that is, because this is a positive 3, it actually goes up 3, which makes sense. Okay, let's do another one real quick just to make sure we have this concept. So y equals x squared. I'm going to put my squared in there again. This time I'm going to do minus 1. Okay, so let me get all this out of the way and let you see this. So again, you notice this red is my parent graph. Here I did negative 1 out to the outside, which moved it down. Okay, so this out here denotes a vertical change, and that vertical change is literal. Okay, now let's do something else here real quick. I'll go ahead and get rid of this one, and I'm going to change this so that now we have a set of parentheses. And inside these parentheses, I'm sorry, this thing's being crazy. I'm going to put in x minus 2, and we'll go ahead and get my squared symbol back again. Notice what happens, okay? Notice what happens. Now, this is a little bit counterintuitive if you think about this, okay? If I look at my parent graph right here, I see that it is centered on the origin right here. But when I put in this negative 2 on my blue graph, all of a sudden it moves to the right. Now, again, vertical changes are literal. If it said plus 3, it went up 3. If it said negative 1, it went down 1. But here, when we're looking at this, when I look at this situation like this, I actually have a horizontal change, not a vertical change, and my change does not do what I thought it would do. I would figure if I put x minus 2, it should go to the left 2. What I want you to understand about this is this negative right here is part of the formula. Okay, so what happens is when you have negative 2, it's actually the opposite. It's actually positive 2. Let's do another one, and you'll see this, I think, a lot more clearly. I'm going to go ahead and copy this is going to make it much easier. And I'm going to change this to a positive 1. Now notice what happens. Notice what happens here. Now all of a sudden my graph moves to the left 1, even though I have a positive 1 over here. So again, a horizontal change does the opposite of what you think it might do, and it moves the opposite of what you'd have it do. So if it says positive 1, it actually moves to the left 1. If it says negative 2, it actually moves to the right 2. All right, so let's look at a few more concepts on this. So I'm going to get rid of these parentheses. And I'm going to change this back to my squared. For some reason, it lost that on me. And this time, I'm going to change this to have a 2 right here. So notice this 2 is directly in front of the x squared, okay, which is very, very important. And notice what happened. My red graph is my parent graph, but my blue graph is now I have changed this to a 2. And what operation is between here? I've got multiplication, right? 2 times x squared. So that means I'm multiplying the function x squared times 2. So what that does in that case is it stretches this graph. Okay, if you think about it, when you stretch up with your hands, it causes your hands to move closer together. So this is called a stretch. Now I want to do something else here real quick, and you're gonna see a different comparison here. So y equals, and this time I'm going to do 1 divided by 2, so 1/2 x squared. Notice what happens now with my purple graph. I'm comparing it to the red graph. So you notice the red graph is my parent graph, and now all of a sudden, when I put 1/2 in here, so I'm multiplying my function x squared by 1/2, or dividing by 2. You could look at it a couple of different ways. Now all of a sudden, this thing is beginning to compress. So think about taking your arms and pressing them down to each side. But when you do that, you're flattening out. Okay, so that's basically what's happening with this graph. It just continues to flatten out. As a matter of fact, if I were to put in another one, let's make it really, really small. So 1 divided by 32 x squared. Notice what happens. It's almost down to the x-axis. And so it really begins to flatten out. So the smaller the numbers you get here, the flatter it becomes. The bigger the numbers you get here, it's going to continue to stretch and stretch and stretch. Okay? So the number that is in front of that determines what that is. And I'm going to go over that in detail here in just a second. So what I had you look at yesterday was basically graph all these things, look at what was happening, describe what was happening there. So at the very bottom of the form, on what you did yesterday, I have this right here. Number 17, consider the following model or pattern of a function. And we have this model here that I laid out for you. So again, my question to you was, what does the A represent? What about the H? And what about the K? Okay, so now I want to switch over. We're going to look at this, and I want to go over this with you in detail and try to hopefully help you be able to figure this out. All right, so we have y equals plus or minus A times the quantity x minus h, all that squared, plus k. Now again, that looks like a bunch of gibberish right now. We're going to make some sense out of this. So notice again when I had y equals negative x squared. Think about what happened. What happened to my graph is that it reflected across the x-axis. And so this right here determines what kind of reflection I have. If it is positive, in this case, in y equals x squared, then I know that the graph is going to go up like that. If it is y equals negative x squared, I know that my graph is going to be downhill like this, okay? So this right here denotes whether it's going to be a reflection or not, okay? Whether it's going to go uphill or whether it's going to go downhill, so to speak. All right, so now let's look at the A. Now remember, this A is directly in front of the x squared term. Now this is a lot like what we did just a few minutes ago with Desmos, where when I put a 2 in front of this, that it really began to stretch. But when I took numbers that were less than 1, all of a sudden it began to compress. So this number that is here determines whether it's a stretch or whether it's a compress. So here's what I want you to understand. It is a stretch if A is greater than 1. So any number greater than 1 is going to make that graph stretch. It's going to come closer and closer and closer together toward the y-axis. Whereas it is a compress if A is between 0 and 1. And that's the way I'm going to write that kind of in compound inequality notation. We've saw some of that already. So if A, this term right here, is between 0 and 1, for example, 1/2 and 1/32, we use several different examples. If it is between 0 and 1, then that graph is going to compress. And again, the smaller that number gets, the more it's going to compress. Okay? Right here, this H term, if you remember when we had equations such as y equals x minus 2 squared, okay, you remember that this notated a horizontal change. So our graph actually moved from left to right, not up and down, but from left to right. So this is a horizontal change, which makes sense because it's got an H there. It's a horizontal change, but what I want you to remember is it is opposite. So this negative is part of the formula, which means that this actually behaves the opposite the way you think it would. In other words, we would think that this should move to the left 2 because it's -2, but it's actually the opposite. This would denote a horizontal shift to the right 2 units. So this is opposite. I want you to kind of make yourself a note of that so that you understand that. And then last but certainly not least, out here, remember when we had an equation where we had, for example, y equals x squared plus 3. So when we had something like that, we remember that this graph actually shifted up 3 units vertically. So it denotes a vertical change when you have a number out here. It denotes a vertical change. And not only that, but it is literal. So what that means is if it says +3, then it actually goes up +3. Okay, so each part of this particular little format, if you will, or formula has a specific part. Again, the plus or minus determines whether it's a reflection or not. The A determines whether it is a stretch or a compress from the parent graph. The H, again, determines whether there's a horizontal change. And remember that horizontal change is opposite of what you might think. And then K denotes a vertical change, which again, we've got to take literal. So again, this format can really help you when you get into certain problems. I'm going to look at just a few examples of things that you're going to see on your practice really quick before I let you go for this video. So this one here, it says y equals f of x, and it wants you to translate it up 3 units. So if y equals f of x is the parent function, then how could I rewrite this in order that I could show that it is going to be translated up 3 units? Well, I'm going to go ahead and write y equals f of x, but remember, if it goes up 3, that means a vertical change. So I need my +3 to be out here on the right side of my equation. So this would be the proper answer for that. If I'm trying to translate y equals f of x, which is my parent function, up 3 units, then I need to put a +3 out here. Okay? Now let's say that I'm being asked to take y equals f of x and move it left 2 units. Well, remember, according to our format up here, if we're going left or right, that is a horizontal change, and so it needs to be written in this format right here. Okay, so vertical changes are out here to this side, horizontal changes are inside the parentheses. So let's go back. It says y equals f of x left 2 units. Well, I'm going to write y equals f, but now when I write my x here, I need something else to be in that parentheses. Well, It says I'm going to move left 2 units. Well, left 2 units, let me think. Coordinate pairs, if I'm going to the negative direction, it'd usually be left, right? So it should just be x minus 2. Well, remember what we just said just a few minutes ago. Horizontal changes are actually opposite of the way you think because there is a negative right there in the formula. So maybe one of the best things you could do when you have a problem like this is to go ahead and put a negative right there. But remember that I'm also moving to the left, which is a negative 2. So a negative would in fact be, and hopefully this is not confusing you, would in fact be x plus 2. And the best way to think about this is it's just the opposite. If you're saying left 2 units, we know that that's usually negative, but when we're writing these, we're going to put it as a positive. And again, you can test this out on Desmos, and you can see that it actually behaves the opposite of the way you think it ought to behave. Okay? Last but certainly not least, is you're going to have problems like this right here. That's going to say y equals, in parentheses, x minus 2 squared minus 3. And what it's going to ask you to do is it's going to ask you to describe the translations that are taking place. So we're just going to move from left to right and see what happens. So I have y equals, and you notice right here I have x minus 2 squared. Well, again, there's nothing in the front, no positive or no negative, so I have to assume that this thing would just turn up. There's not a reflection. I also notice that there's nothing here in my A term. So I know that it's not being stretched or compressed. So I can rule out those two things. I don't have a reflection, and I don't have a stretch or compress. Now I'm going to move on to here. And remember, when I have something inside parentheses other than just the x, then I know that there has to be a horizontal change. So for this particular example, I know that there is a horizontal change, but I have to describe that. So horizontal change. And again, if it's a negative 2, then I know that I'm actually going to do what? I'm actually going to move in the opposite direction because horizontal changes are opposite. So if it says negative 2, that means I'm actually going to move to the right 2 units. Okay? Now, I look over here. If you notice, out to the right of my x squared term, I have a negative 3. Now, that negative 3 that's out here, again, what does that denote? Well, that denotes a vertical change. Okay? And remember, our vertical change is in fact literal. So if this says negative 3 on our coordinate grid, if we were looking at the vertical changes, which are up and down like this, if it says negative 3, that means I'm actually going to move down 3 units for this translation. So that's basically all you have to do when you're given that type of problem. Hopefully this has been helpful. And of course, just let me know if you have any questions or concerns.